Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, I'm going to present about presentation for the subject DJA 20013 Automotive Technology. I'm gonna introduce myself first. My name is Muhammad Afiq bin Shalwan. My metric number is 04DAD23F1051 from class DAD 2B. Okay, here I'm going to show you the question that are given, the task that are given to me for me to answer in our video. There are 12 questions so far, so I've already answered all the question in this video. Okay, for the first question, demonstrate how to calculate the displacement cc of the engine and give one example of the calculation. We are going to calculate the displacement. The formula for the displacement is cc equals pi per 4 times cylinder bore square times strokes times number of cylinder, or cc equals pi per square times B for cylinder bore square times S for strokes times NC for number of cylinder. So on this question, it tells me to give one example. So here is my example for this question. For example, in a 4-cylinder engine, the stroke length is 10 cm and the bore is 5.5 cm. What is the displacement? Since n is 4, s is 10, b is 5.5, the displacement in cubic centimeter is 950.23. It's just a simple math, if you ask me. Just times. Here is my example. Okay, for the next question. Question 2. Demonstrate and explain the term of firing order. So, firing order is the sequence in which the cylinder deliver their power stroke. It is designed into the engine. The crank pin and crankshaft arrangement determine the firing order. In most engines, the firing order evenly distributes the power strokes along the crankshaft. Most designs avoid firing two cylinders, one after the other. At the same end of the crankshaft, firing order for the same type of engine may differ. For the next question, here it's very easy. The firing order is very easy. For the next question 3. Demonstrate how the valve overlap timing can affect engine performance. So, valve overlap, it can affect the engine performance as illustrated in valve timing diagram. The intake valve opens at 12 BTDC and closes at 56 degrees at ABDC. This permits additional air-fuel mixture will still drawn into the cylinder because of the intake manifold velocity. The exhaust valve opens at 47 degrees BTDC on the power stroke. This will help to force exhaust gases from the cylinder. The exhaust valve closes at 21 degree ATDC when both valves are open for a short period of crankshaft rotation ATDC on the exhaust stroke. The incoming air-fuel mixture helps purge any exhaust gas from the cylinder. Early overlap may result in exhaust gases being expelled into the intake manifold, and late overlap may result in exhaust gas being drawn back into the cylinder. So this is my answer for question 3. It's quite simple. Next question 4. Demonstrate and explain the MyVac system in engine technology. MyVac system, or it's called Mitsubishi Innovative Valve Timing Electronic Control System, is a brand name of the variable valve timing (VVT) engine technology developed by Mitsubishi Motors. MyVac, as with other similar systems, varies the timing of the intake An exhaust camshaft will increase the power and torque output over a broad engine speed range, while also being able to help spool a turbocharge more quickly. Although initially designed to enhance performance, the system has subsequently been developed to improve economy and emission, and has been introduced across Mitsubishi's range of vehicles. In summary, MyVet switched to the higher cam profile as engine speed increase, and drops back to the lower cam profile as engine speed decrease. The reduced valve overlap in a slow speed mode provides stable idling, while accelerated timing of the intake valve closing reduces backflow to improve volumetric efficiency, which helps increase engine output as well as reduce lift friction. High speed mode takes advantage of the positive intake effect created by the mode's high lift and retarded timing of intake valve closure. The resulting reduced pumping loss of the larger valve overlap yields higher power output, and the reduction in friction. The low and high speed modes overlap for a brief period, boosting torque. So that is for question 4. For the next question 5. Demonstrate and explain the operation of engine cooling system. Engine cooling system. The burning air fuel mixture in this engine cylinder may reach 4,000 Fahrenheit or 2,200 Celsius or higher. This means engine parts get hot. However, cylinder wall must not get hotter than above 500 degrees Fahrenheit or 260 degrees Celsius. Higher temperature causes lubricating oil to break down and lose its lubricating ability. Other engine parts are also damaged. To prevent overheating, the cooling system removes the excess heat. At the same time, an engine that is cooled is very inefficient, runs poorly, contaminates the oil, forms deposits, increase wear, cut down horsepower, and will not achieve good fuel mileage. Type of internal engine, type of cooling system, air cooling system, and water. Water cooling system. There are two types of engine cooling system. For air cooling system, a small engine uses air cooling system for reducing weight and complexity. Notice the rows of fins on both the cylinder blocks and the cylinder head. The fins provide additional surface for air to pass over the cylinder and absorb it. And then water cooling system. It is to maintain the highest and most efficient operating temperature within the engine. It also can remove excess heat from the engine and to bring the engine up to operating temperature. For the next question 6. Demonstrate and explain the magneto-ignition system. Magneto-ignition system. Magnet. It has the same principle of working like that of the battery ignition system. In this, no battery is required, as the magneto acts as its own generator. Yes. In a magneto-ignition system, it consists of either rotating magnets in fixed coils or rotating coils in fixed magnets. The current produced by the magneto is made to flow to the induction coil, which works the same as that of the battery ignition system. This high voltage current is then made to flow to the distributor, which connects to the spark plug in the rotation depending upon the firing order of the engine. This type of ignition system is used small spark ignition engine, for example scooters, motorcycles, and small motorbike engines. Next question 7. Demonstrate the operation of ignition system. Operation of ignition system. Ignition system ignition system is one of the most important systems used in the LC and IC engine. The spark ignition engine requires some device to ignite the compressed air filter. The ignition takes place inside the cylinder at the end of the compression stroke. Ignition systems serve this purpose. There are two types of ignition system. There are three types of ignition system. Battery ignition system or coil ignition system. Second one, magneto ignition system. Third one, electronic ignition system. Both the ignition system is used on the principle of common electromagnetic induction. The battery ignition system is mostly used in passenger cars and light trucks. In the battery ignition system, the current in the primary winding is supplied by the battery in the magneto to the ignition system. The magneto produces and supplies the current in the primary winding. There are 5 parts of an ignition system: battery, switch, ignition distributor, ignition coil, spark plugs, and necessary wiring. Some systems use transistor to reduce the load on the distributor contact points. Other systems use a combination of transistor and a magnetic pickup distributor. Compression ignition engine does not have such an ignition system. In a compression ignition engine, only air is compressed in the cylinder, and at the end of the compression stroke, the fuel is injected while catch fire due to the high temperature and pressure of the compressed air. Next question, question 8. Demonstrate and explain the difference between recirculating ball steering system and rack pinion steering system. Recirculating ball. With the manual recirculating ball system, turning force are transmitted through ball bearing from a worm gear on the steering shaft to a sector gear on the pitman arm shaft. A ball nut assembly is filled with a ball bearing, which roll along grooves between the worm tip and grooves inside the ball nut. When the steering wheel is turned, the worm gear on the end of the steering shaft rotates, and movement of the recirculating ball causes the ball nut to move up and down during the worm. Movement of the ball nut is carried to the sector gear by teeth on the side of the ball nut. The sector gear then moves to the tip of the ball nut to rotate the pitman arm shaft and activate the steering linkage. The ball is recirculated from one end of the ball nut to the other through ball return guides. And what about rack and pinion? A typical rack and pinion steering gear assembly consists of a pinion shaft and bearing assembly, rack gear, rack housing, 2 tie rod assemblies, and adjuster assembly, dust boots, and boot clamps, and grommets, mounting, and bolts. When the steering wheel is turned, this manual movement is relayed to the steering shaft and shaft front, and to the pinion shaft. Since the pinion teeth mesh with the teeth on the rack gear, the rotary motion is changed to transpose movement of the rack gear. The tie rods ends then transmit this movement to the steering knuckles and wheels. Next question, question 9. For question 9, demonstrate and explain how to execute the power steering pump bleeding a power steering pump. When any of the hydraulic component, pump, hose, power piston are serviced, you should bleed the power steering system. Bleeding a power steering system assures that all of the air is out of the lines, pump, and gearbox. To bleed out any air, start the engine and turn the steering wheel fully from side to side. Keep checking and adding fuel as needed. This will force air into the reservoir and out of the system, or air can cause the power steering system to make a buzzing sound. The sound will appear as the steering wheel is turned right or left. Question 10. Demonstrate and explain the difference between the sprung and unsprung weight. Sprung weight refers to the weight of all parts of the car that are supported by the suspension system. The frame, engine, body all make up the sprung weight. Unsprung weight refers to all parts of the car that are not supported by the suspension system. Wheels, tires, steering knuckles, rear axle assembly, and etc. The ideal situation is to have the unsprung weight as small as possible in relation to the sprung weight. The unsprung weight will then have minimum effect on the riding characteristic of the car. Next question, question 11. Demonstrate and explain the difference between wishbone and McPherson strut suspension system. Wishbone suspension system. Two links of the parallel and normal right position are made in a wishbone shape to provide for and of the stiffness and resist braking torque. Each wishbone has three bearings, two inner bearings connecting with the frame and outer one attaching to the stop axle carrier, rubber or plastic. Brushes are fitted at the inner ends of the wishbone, and in many cases, a ball joints at the outer are enabled the double axle to swivel. Early design used wishbones of equal lengths, but the track variation caused considerable tire wear. This can be reduced by using wishbone of unequal lengths. The longer one at the bottom, but change in chamber angle will now have to be tolerated. A constant caster angle is achieved with this design by mounting the top wishbone slightly behind the lower one, in order to obtain the maximum wishbone length without restricting engine space. The wishbone axis is sometimes inclined toward the rear. Either the piston type damper is mounted to incorporated the inner bearing for the top wishbone, or telescopic damper is fitted in the center of the coil spring. In case where torsion bar springing is used, a large movement of telescopic damper can be achieved by mounting the damper diagonally. The lower end is connected to the outer of the lower wishbone, and the upper end to a point on the frame just above the upper wishbone. And then about McPherson strut suspension system. This incorporates a single control arm that is connected to a long tube called strut. Shock absorber, strut, and spindle are integrated as one unit and supported by a coil spring at the upper end and a lower control arm at the lower end. A ball joint is fixed at the lower end of the spindle. The lower control arm is also called as a transverse link. The lower arm is held down by a straight stabilizer bar. Next question, question 12. Or last question. Demonstrate and explain the operation of single acting telescopic shock absorber. Shock absorber limits spring oscillation. What is oscillation? Compression, extension, movement to smooth the car ride. Without shock absorber, the car will continue to bounce up and down after striking a dip or hump in the road. This will make the ride uncomfortable and unsafe. Figure show the basic parts of the shock absorber. They include a piston rod, rod seal, piston reservoir, operation cylinder, extension cylinder, and full flow control valves. Most are filled with oil, some are full, or some are air or gas, and oil fluid. When the shock is compressed or extended, the oil causes resistance to the movement. The rod tends to drag slowly in or out. This tempered spring and suspension system action. One end of the shock absorber connects to a suspension component, usually a control arm. The other end of the shock fastens to the frame. In this way, the shock rod is pulled in and out to restrain movement. The shock absorber compression occurs when the car's tire is forced upward upon hitting a bump. Shock absorber extension is the outward movement of the piston and rod as the control aid moves down This occurs right after the compression stroke or when the tire rolls over a hole in the road. That is for my last question. So we are going to end. I'm going to end my presentation here. I've already answered all 12 questions so far. So thank you very much for hearing.